Now 2010 A1, so short question. The flight paths of two aircraft are represented by the two skew lines A, B and CD. Determine the projections of the shortest distance between the two skew lines. So if you remember back, we could be asked either for the shortest distance between the skew lines or the shortest horizontal distance between the skew lines. Now, the previous worksheet there, which we were working on last week, this was how we found the shortest distance. So we created a plane, first of all, containing one of the skew lines, and one of the other edges of the plane was parallel to our second skew line. We then got an edge view of that plane, so our two skew lines appeared to be parallel, and we looked perpendicular then to where the skew lines appeared to be parallel. That's for the shortest distance. If we were asked shortest horizontal distance, we look along the x1, y1. But this is the method that we're going to do today. Now, as you remember as well, everything up to this stage of the question is the same. It's only the second auxiliary view that changes. So, what I'm going to do is I'm going to create a plane containing one of the skew lines. Now, there are several ways that you could do this. So you could draw a plane that contains the line CD. You could also draw a plane that contains the line AB. And both methods, or both lines, whatever plane you create, would all get you full marks. Now, today I am going to create a plane containing the line AB. So, to create the plane, I'm going to go and draw a parallel line, so parallel to my other skew line CD, and I'm going to draw that there from point B. Okay, so I could also, if I wanted to create a plane containing the line CD, I could go parallel to the line AB and say bring that up from point C and then go horizontal across from D. That would just mean I was crossing over onto where the text is here. Next step then is a horizontal line from point A and that there is going to give me point P. And as before, we have a parallel line on my plane which is parallel to a skew line. So those two lines are parallel. Now I want to find point P in my plan, and I have my triangular plane ABP there now. So I'm going to drop point P straight down to the plan. The line BP is parallel to CD. Well, it still has to be parallel to CD in the plan because parallel lines remain parallel in every view. So parallel there to CD from point B. And then where it hits my projection line, that gives me point P, and I can complete my plane by joining it back to A, like so. Now, because the line AP is horizontal in the elevation, it will be a true length line in plan, and my next step now is to go and look along that true length line. So I'm going to project an auxiliary view looking along that line. Now I will take heights from the elevation, and I'm also going to actually put in a datum line. My elevation going through point C. C is the lowest point. And I'm also going to drop down just each point there as well. Okay, so just make sure you label your datum line there as well when you're drawing it in. And then I'll take my heights for each point. Now you'll actually notice there A and D are both the same height. and then no height for C's that's on my datum line. So I'll just label all of those. And then I'll join A and B and C and D. And I know I'm on track because my skew lines are appearing parallel to one another. Next thing then, so to determine the shortest distance between them, I will now project an auxiliary view looking 90 degrees to my parallel lines. Now, next thing then, I would count back. So here's my second auxiliary view. I'm counting back 1, 2 views for my distances. I don't need to worry about point P anymore. So I'm going to go and put in a second datum line parallel to my X1, Y1. And that is going to pass through point B. There's my second datum line. And I will go and measure then the distances from that to each of my points. And then I'm just joining A to B and C to D. And I'll see where they appear to cross over. And if we look back, determine the projections of the shortest distance. So I need to now draw the line in all my views which shows the shortest distance. So where they appear to cross over, I'm just going to project it back through each of my views. So there it is, and I'm going to call that line 1, 2. So point 1 is on the line AB, and point 2 is on the line CD. And then lastly, project it up to the elevation. And that there is the projections of the shortest distance between the two skew lines. So that's part A finished. Part B, determine and indicate the length of this shortest distance. Where we actually see the true length of that shortest distance is in my first auxiliary view. The reason I know this is a true length is because when I look along that line, it appears as a point in my next view. So all I need to do now is just highlight there that is the shortest distance. So we have all the work done, we're just indicating. And I would say as well, measure that in millimeters and write it in beside your shortest distance.